Alright, this topic's called finding a specific term of a geometric sequence with a given ratio and with a given first term. There's a lot of words in that title that might not mean a whole lot to you. So let's start with what a geometric sequence is. A geometric sequence is a list of numbers, and for each number, like let's say we start with 1, and I multiply it by 3. To get my next number, I'll take the 3 and multiply it by 3, which gives me 9. To get the next number, I take my 9 and multiply it by 3 to give me 27. 27 times 3, which I'm thinking is 81. And you just keep going on and on. It goes on to infinity. That's what a geometric sequence is. That's a real basic one. You can get some real ugly ones that multiply. I don't want to do this out in my head, but I'll do a couple. Let's say that we start off with 1 and we multiply it by a half. That's going to give us a half. We multiply the half by a half. It's going to give us a fourth. If we multiply it by the 1/4 by a half, we get an eighth. And so you can see how this number is going to get smaller and smaller into this tiny little fraction. But there's a lot like this one here with the fractions that are kind of ugly, and what's going to happen in math classes, you're going to be asked to find, they're going to give you the beginning of a sequence, and they're going to say, alright, what I want you to do is find the 20th term. So in this one here, you're going to have to end up with this huge number on the bottom of your fraction. This one up here is not going to be too bad, but you're going to end up with a very big number. And sometimes they'll give you a problem where your ratio, or what you're multiplying by, is something like 2/3, so it's not as clear cut. So let's talk about that. The ratio, or what they call the common ratio, is the number you're multiplying by every term. So it's the number you multiply by. So in the first example, our ratio is 3. And we're going to use, for the variable for ratio, we're going to say r. Kind of makes sense, right? For our second example, the ratio was a half, because we were multiplying every number by a half. So ratio, now we know what that means. Geometric sequence, we've defined that. It's just a list of numbers where you take the last number and multiply it by a specific ratio. First term, well, that's kind of common sense. This example here, if 1 is your first term, our second example one is also a first term. It doesn't always have to be 1, it just happened that that's the one I chose. So you want to get your handy dandy notebooks out if you don't already have them, and you want to write down this formula, because like I said, if you had your second example here and someone wanted you to find like the 25th term, you're going to take a while to do that. And there is a really cool formula to make it a lot easier, and here it is. A sub n, that's how you say A with that little n. A sub n equals A sub 1 times r, and here's an exponent, n minus 1. Alright, so that might be a little scary. In a minute we're going to talk about what all these letters are for, but I want you to just know that if you use this and then you follow the order of operations, you'll be absolutely fine. Alright, I ran out of room. Let me slide this up a little bit. Alright, what are all these letters? So A sub n, that's the term, the answer we're looking for. We're looking for A sub 1, that's just a fancy way or short way of writing the first term. R is your ratio. And n is your term number that you're looking for. Alright, so make sure you have that written down. Make sure you have all these little arrows and stuff like I put in, so that when you go back to look at your notes in a month, when you get this on an assessment or something, you'll be like, oh yeah, now I can read through my notes and I'll understand it. So let's do an example together. Here is, what is the 7th term of a geometric sequence? I'm going to abbreviate that. What is the 7th term of a geometric sequence with a ratio of 2/3? That's kind of a gross ratio. And a first term of 4. Alright. What is the 7th term of a geometric sequence with a ratio of 2/3 and a first term of 4? Scroll it up a little so I have a little more room. let's go through what I just wrote and what you just wrote, and let's label things. What is the 7th term? 7th term, so that's going to be our n value. We're looking for term number 7 of a geometric sequence with a ratio of 2/3. So 2/3 is our r value, and a first term of 4. 4 is our a sub 1. It's our first term. Alright, so I scrolled up beyond our formula, so let me recopy it here. A sub n equals a sub 1 times r to the n minus 1. Alright, let's plug everything in. A sub n we don't know. A sub 1 we know is 4 times r is 2/3, and we need to raise the 2/3, I'm going to put in parentheses, to the n minus 1, 7 minus 1. Applying the order of operations, we're going to take care of that exponent and do the 7 minus 1 on it. So 7 minus 1 is 6. Now we're going to apply our exponents. 2 to the 6 times 3 to the 6. I have no idea what that is. 2 to the 3rd is 8. 16, 32, so that's going to be 64. And 3 to the 6th, I have no idea. I know 3 to the 4th is 81 times 3. That's 3 to the 5th times 3 again. 9, 12, 729. Wow, that's a big number. Finally, what I need to do is I need to multiply. I'm going to scroll up just a little bit so I can write it the way I want to. I can change that 4 to a fraction, 4 over 1. So now, just to remind you, how do we multiply fractions? Tops times tops and bottoms times bottoms. So 4 times 64, I don't know that off the top of my head either. 4 times 4 is 16. 24, 256. So we have 256 over 729. That's going to be your final answer. And I know that this might have been a little intimidating using this formula, like with all the different, raising the 2/3 to the 6th power. But your teacher might let you use a calculator to get the 64 and to get these two numbers here. And if not, it's just going to be a heck of a lot easier than going through taking a number, multiplying it by 2/3, taking that answer, multiplying it by 2/3, taking that answer, multiplying it by 2/3, and doing that 7 times in a row. Trust me. Let's do another example. Alright, let's try finding some space. Okay. What is the 6th term of a geometric sequence with a common difference of, we'll say, 3/2, and a first term and we'll say a first term of 5. If you need to take a little more time to write that out, hit pause and then hit play when you're ready to move on. I'm going to put this formula back here because it makes it handy to have it. Alright. Reading through the problem, what is the 6th term? So the 6 is our n value of a geometric sequence with a common difference of 3/2, that's our r value, and a first term of 5, that's a sub 1. So now that we have things labeled, let's plug them in. A sub n equals a sub 1 is 5 times our common ratio is 3/2, and the exponent is n minus 1, so 6 minus 1. When we rewrite this, 5 times 3/2, 6 minus 1 is 5. And again, the order of operations, I meant to mention this earlier. It's just the 3/2 that's being raised to the 5th. Order of operations says you do exponents before you multiply. So that's why we're applying the 5th power to the 3/2. We're not multiplying the 5 times the 3/2 and then raising it to the 5th power. Alright, so 3 to the 5th, anyone have that written down from what I said? 3 to the 4th is 81. 3, so that's 243. 2 to the 5th 2 to the third is 8. 2 to the fourth is going to be 16. 2 to the fifth is 32. And again, I'm just going to rewrite that as 5 over 1 times 243 over 32. And I need to multiply 243 times 5. 243 times 5. 21, 10, 11, 12. Huh. I'm out of room. 12, 15 over 32. And again, if you don't believe me that using the formula is easier, feel free to start off by going 5. That'll be your first one. Multiplying that times 3 halves. And that would give you 15 halves. And then multiplying that by 3 halves. And putting that answer down and multiplying that answer. And you have to do that 6 times. You got a lot of multiplying of fractions to do. You have to do 6 different times of that. And it could just end up being, it's a lot more room for error than using the formula. Let's do one more example, and on this example I want you to write down the problem, hit pause, work it out in your notebook, and then hit play and see if we get the same answer. Alright, this final problem for this set. Let's say we have a geometric sequence for the first term. Of 3 and a ratio of 1/2. What is the 7th term? My formula has disappeared. Always start with your formula. Times r to the n minus 1. We have a geometric sequence with a first term of 3, so that's our a sub 1, and a ratio of 1/2, so that's our r. What is the 7th term? So 7 is our n. So now we can plug things in. A sub 1 is 3 times our ratio of 1/2, and the 1/2 is going to be raised to the 7 minus 1 power, which is 3 times 1/2, 7 minus 1 is 6. 1 to the 6th power is 1. 2 to the 6th power, I had this figured out before, but I've forgotten it. So 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. So 2 to the 6th is going to be 64. And that's the same as 3 over 1 times 1 over 64. So our final answer is 3 over 64. Alright, I hope you got the same answer. If you didn't, or if there are a few things that you're a little bit confused on, why don't you come find me and I'll see if I can help you out. Thanks for listening.